Openstax.org, Contemporary Mathematics, Chapter 1, Section 4. Set operations with two sets. Figure 1.18. A large multi-generational family contains an intersection and a union of sets. Credit. And it's just a picture of, looks like an Indian or an Islamic family. Learning objectives. After completing this section, you should be able to 1. Determine the intersection of two sets. 2. Determine the union of two sets. 3. Determine the cardinality of the union of two sets. 4. Apply the concepts of and or to set operations. 5. Draw conclusions from Venn diagrams with two sets. The movie Yours, Mine, and Ours was originally released in 1968 and starred Lucille Ball and Henry Fonda. This movie, which is loosely based on a true story, is about the marriage of Helen, a widow with 8 children, and Frank, a widower with 10 children, who then have an additional child together. The movie is a comedy that plays on the interpersonal and organizational struggles of feeding, bathing, and clothing 20 people in one household. If we consider the set of Helen's children and the set of Frank's children, then the child they had together is the intersection of these two sets, and the collection of all their children combined is the union of these two sets. In this section, we will explore the operations of union and intersection as it relates to two sets. The intersection of two sets. The members that the two sets share in common are included in the intersection of two sets. To be in the intersection of two sets, an element must be in both the first set and the second set. In this way, the intersection of two sets is a logical AND statement. Symbolically, A intersection B is written as the set A intersects the set B. It's like an upside down U. A intersection B is written in set builder notation as set A intersect set B equals bracket X, such that X is an element of A and X is an element of B, close. Let us look at Helen's and Frank's children from the movie Yours, Mine, and Ours. Helen's children consist of the set H equals bracket Colleen, Nick, Janet, Tommy, Jean or John, Philip, Gerald, Teresa, Joseph, close. And Frank's children are included in the set F equals the set Mike, Rusty, Greg, Rosemary, Luis, or I guess Lois, Susan, Veronica, Mary, Jermaine, Joan, and Joseph. Set H intersection set F is the set of children they had together. Set H intersects set F equals bracket Joseph, close, because Joseph is in both set H and set F. Example 123. Finding the intersection of set A and set B. Set A equals bracket 1, 3, 5, 7, 9, close, and set B equals the set 2, 3, 5, 7. Find set A intersection set B. Solution. The intersections of sets A and set B include the element that set A and set B have in common, which is 3, 5, and 7. Set A intersection set B equals the set 3, 5, 7. Your turn, 123. Set A equals the set HAPY, and set B equals the set SAD. Find set A intersection set B. Notice that if sets A and set B are disjoint sets, then they do not share any elements in common, and set A intersection set B is the empty set as shown in the Venn diagram below. Here we have figure 119. We have a yellow rectangle labeled U, and then two blue squares labeled, or circles labeled A and B, and the circles are disjoint, i.e. not touching or connected in any way. Example 124. Determining the intersection of disjoint sets. Set A equals the set 0, 2, 4, 6, 8, and set B equals bracket 1, 3, 5, 7, 9, close. Find set Set A intersection set B. Solution. Because set A and set B are disjoint, they do not share any elements in common. So the intersection of set A and set B is the empty set. Or set A intersection set B equals the circle with the line through it, the empty set. Your turn 124. Set A equals the set red, yellow, blue, and set B equals the set orange, green, purple. Find set A intersect set B. Notice that if set A is a subset of set B, then set A intersection set B is equal to set A, as shown in the Venn diagram below. So here we have figure 120. Yellow rectangle labeled U for the universal set. Dark blue circle inside completely of a light blue circle labeled B, and B is completely inside of U. So it's like nested circles or subsets. Example 125. Finding the intersection of a set and a subset. Set A equals the set 1, 3, 5, so on. And set B equals the natural number set, which equals the set 1, 2, 3, so on. Find set A intersect set B. Solution. Because set A is a subset of set B, set A intersection set B is equal to set A. Set A intersect B equals set A, which equals the set 1, 3, 5, and so on. The set of odd natural numbers. Your turn 125. Set A equals the set A, B, C, ellipsis, Z, and set B equals the set A, E, I, O, U. Find set A intersection set B. The union of two sets. Like the union of two families in marriage, the union of two sets includes all the members of the first set and all the members of the second set. To be in the union of two sets, an element must be in the first set, the second set, or both. In this way, the union of two sets is a logical inclusive OR statement. Symbolically, set A union set B is written as set A union set B. Set A union set B is written in set builder notation as set A union set B equals bracket X such that X is an element of A or X is an element of B, close. Let us consider the sets of Helen's and Frank's children from the movie Yours, Mine, and Ours Again. Helen's children is the set H equals the set Colleen, Nick, Janet, Tommy, John, Philip, Gerald, Teresa, Joseph, and Frank's children is set F equals the set Mike, Rusty, Greg, Rosemary, Lois, Susan, Veronica, Mary, Jermaine, Joan, Joseph. The union of these two sets is the collection of all 19 of their children. Set H union set F equals the set Colleen, Nick, Janet, Tommy, John, Philip, Gerald, Teresa, Joseph, Mike, Rusty, Greg, Rosemary, Lois, Susan, Veronica, Mary, Jermaine, Joan. Notice Joseph is in both set H and set F, but he is only one child, so he is listed only once in the union. Example 126. Finding the union of sets A and set B when set A and set B overlap. Set A equals bracket 1, 3, 5, 7, 9, close, and set B equals bracket 2, 3, 5, 7, close. Find set A union set B. Solution. Set A union set B is the set formed by including all the unique elements in set A, set B, or both sets A and set B. So set A union set B equals bracket 1, 3, 5, 7, 9, 2, close. The first 5 elements of the union are the 5 unique elements in set A. Even though 3, 5, and 7 are also members of set B, these elements are only listed one time. Lastly, set B includes the unique element 2, so 2 is also included as part of the union of sets A and set B. Your turn 126. Set A equals the set HAPY and set B equals the set SAD. Find set A union set B. When observing the union of sets A and set B, Notice that both set A and set B are subsets of set A union set B. Graphically, set A union set B can be represented in several different ways depending on the members that they have in common. If set A and set B are disjoint sets, then set A union set B would be represented with two disjoint circles within the universal set as shown in the Venn diagram below, figure 121. So yellow rectangle is the universal set, and we have two circles, A and B, both blue, both disjoint, and figure 121, that's set A union set B. If sets A and set B share some but not all members in common, then the Venn diagram is shown as two separate circles that overlap. Okay, I see. So, yeah, the first one, figure 121, is disjoint. Second one, they're joint. Same color scheme. However, the part where A and B combine is slightly darker than A and B by themselves. And then, if every member of set A is also a member of set B, then set A is a subset of set B, and set A union set B would be equal to set B. To draw the Venn diagram, the circle representing set A should be completely enclosed in the circle containing set B. And so now, set A is completely within set B. It's that same nested one from figure 120. Example 127. Finding the union of sets A and set B when set A and set B are disjoint. Set A equals bracket 0, 2, 4, 6, 8 close, and set B equals bracket 1, 3, 5, 7, 9 close. Find set A union set B. Solution: because sets A and B are disjoint, the union is simply the set containing all the elements in both set A and set B. So set A union set B equals bracket 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 close. Your turn 127. Set A equals the set red, yellow, blue, and set B equals the set orange, green, purple. Find set A union set B. Example 128. Finding the union of sets A and set B when one set is a subset of the other. So set A is bracket 1, 3, 5 ellipsis, close, and set B equals the natural numbers, which equals the set 1, 2, 3, and so on. Find set A union set B. Solution: because set A is a subset of set B, set A union set B is equal to set B. So set A union set B equals the natural numbers, and that equals bracket 1, 2, 3 ellipsis, close, which equals set B. Your turn 128. Set A equals bracket A, B, C, ellipsis, Z, close, and set B equals bracket A, E, I, O, U, close. Find set A union set B. And then here's a video, the basics of intersection of sets, union of sets, and Venn diagrams. Tech check. Set operation practice. Sets Challenge is an application available on both Android and iPhone smartphones that allows you to practice and gain familiarity with the operations of set union, intersection, complement, and difference. Figure 124, Google Play Store image of Sets Challenge game. Credit goes to them. The Sets Challenge application game uses some notation that differs from the notation covered in the text. 1. The complement of set A in this text is written symbolically as set A with an apostrophe, or A prime, but the Sets Challenge game uses set A with a superscript capital C to represent the complement operation. 2. In the text, we do not cover set difference between two sets, set A and set B, represented in the game as set A minus set B. In this game, this operation removes from set A all the elements in the intersection of sets A and B. For example, if set A equals the set A, B, C, D, and set B equals the set B, D, F, H, are subsets of the universal set, set U equals the set A, B, C all the way to Z, then set A minus set B equals the set A, B, C, D minus the set B, D equals the set AC. And set B minus set A equals the set BDFH minus the set BD, which equals the set FH. There is a project at the end of the chapter to research the set difference operation. Determining the cardinality of two sets. The cardinality of the union of two sets is the total number of elements in the set. Symbolically, the cardinality of set A union set B is written n of set A union set B. If two sets A and set B are disjoint, the cardinality of set A union set B is the sum of the cardinality of set A and the cardinality of set B. If the two sets intersect, then set A intersection set B is a subset of both set A and set B. This means that if we add the cardinality of set A and set B, we will have added the number of elements in set A intersection set B twice. So we must then subtract it once, as shown in the formula that follows. Formula. The cardinality of set A union set B is found by adding the number of elements in set A to the number of elements in set B, then subtracting the number of elements in the intersection of set A and set B. So, n of set A union set B equals n of set A plus n of set B minus n of set A intersect set B, or n of set A or set B equals n of set A plus n of set B minus n of set A and set B. Caution: if sets A and set B are disjoint, then n of set A intersects set B equals n of set A and set B equals 0. And the formula is still valid, but simplifies to n of set A union set B equals n of A plus n of B. Example 129. Determine the cardinality of the union of two sets. The number of elements in set A is 10, the number of elements in set B is 20, and the number of elements in set A intersection set B is 4. Find the number of elements in set A union set B. Solution. Using the formula for determining the cardinality of the union of two sets, we can say n of set A union set B equals n of set A plus n of set B minus n of set A intersects set B equals 10 plus 20 minus 4 equals 26. Your turn 129. If n of A equals 23, n of B equals 17, and n of set A intersects set B equals 7, find n of set A union set B. Example 130. Determining the cardinality of the union of two disjoint sets. If set A and set B are disjoint sets and the cardinality of set A is 37 and the cardinality of set B is 43, find the cardinality of set A union set B. Solution. To find the cardinality of set A union set B, apply the formula. I'm going to call this n of A union B. Yeah, I'm going to just start omitting set just to make it easier, quicker. That equals, so n of A union B equals n of A plus n of B minus n of A intersect B. Because sets A and B are disjoint, A intersect B is the empty set. Therefore, n of A intersect B equals n of the empty set equals equals 0, and n of A union B equals 37 plus 43 minus 0 equals 80. Your turn 130. If the intersection of sets A and B equals the empty set, n of A equals 35, and n of B equals 78, then find n of A union B. Applying concepts of and or to set operations. To become a licensed driver, you must pass some form of written test and road test, along with several other requirements depending on your age. To keep this example simple, let us focus on the road test and the written test. If you pass the written test but fail the road test, you will not receive your license. If you fail the written test, you will not be allowed to take the road test, and you will not receive a license to drive. To receive a driver's license, you must pass the written test and the road test. For an and statement to be true, both conditions that make up the statement must be true. Similarly, the intersection of two sets A and B is the set of elements that are in both set A and set B. To be a member of A intersection B, an element must be in set A and also must be in set B. The intersection of two sets corresponds to a logical AND statement. The union of two sets is a logical inclusive OR statement. Say you are at a birthday party and the host offers Leia, Lenny, Maya, and you some cake or ice cream for dessert. Leia asks for cake, Lenny accepts both cake and ice cream, Maya turns down both, and you choose only ice cream. Leia, Lenny, and you are all having dessert. The OR statement is true if at least one of the components is true. Maya is the only one who did not have cake or ice cream. Therefore, she did not have dessert, and the OR statement is false. To be in the union of two sets, A and B, an element must be in set A or set B, or both set A and set B. Example 131. Applying the AND or OR operation. So we have set A equals the set 0, 3, 6, 9, 12, and set B equals the set 0, 4, 8, 12, 16, and set C equals the set 1, 2, 3, 5, 8, 13. Find the set consisting of elements in 1. Set A and set B, 2. Set A or set B, 3. Set A or set C, 4, and then this is in parentheses, set B and set C, close, or set A. Solution. So we have A and B equals A intersect B equals the set 0, 12, because the only the elements 0 and 12 are members of both set A and set B. A or B, which equals, 2. A or B equals A union B, which is the set 0, 3, 4, 6, 8, 9, 12, 16, because the set A or B is the collection of all elements in set A or set B, or both. 3. A or C, that's A union C, which equals set 0, 1, 2, 3, 5, 6, 8, 9, 12, 13, because the set A or C is the collection of all elements in set A or set C, or both. And then 4, B and C, or A, equals the intersection of B and C union with A. Parentheses are evaluated first, so B and C is B intersects C, which is the set 8, because the only member that both set B and set C share in common is 8. So now we need to find the set 8 or the set 0, 3, 6, 9, 12. Because the word translates to the union operation, the problem becomes the set 8 union the set 0, 3, 6, 9, 12, which is equal to the set 0, 3, 6, 8, 9, 12. Your turn 131. Set A equals HAPY. Set B equals the set AWESOM, and set C equals the set MATH. Find the set consisting of elements in 1. A or B, 2. A and C, 3. B or C, 4. Parentheses A and C, close, and B. Example 132. Determine and apply the appropriate set operations to solve the problem. Don Woods is serving cake and ice cream at his Juneteenth celebration. The party has a total of 54 guests in attendance. Suppose 30 guests requested cake, 20 guests asked for ice cream, and 12 guests did not have either cake or ice cream. 1. How many guests had cake or ice cream? 2. How many guests had cake and ice cream? Solution. 1. The total number of people at the party is 54, and 12 people did not have cake or ice cream. Recall that the total number of elements in the universal set is always equal to the number of elements in a subset plus the number of elements in the complement of the set. N of U equals N of A plus N of A prime. That means 54 equals N of cake or ice cream plus N of not cake or ice cream, or equivalently, N of cake union ice cream equals 54 minus N of cake union ice cream complement, which equals 54 minus 12 equals 42. A total of 42 people at the party had cake or ice cream. 2. To determine the number of people who had both cake and ice cream, we need to find the intersection of the set of people who had cake and the set of people who had ice cream. From question 1, the number of people who had cake or ice cream is 42. This is the union of the two sets. The formula for the union of two sets is N of A union B equals N of A plus N of B minus N of A intersect B. Use the information given in the problem and substitute the known values into the formula to solve for the number of people in the intersection. 42 equals 30 plus 20 minus n of A intersect B. Adding 30 and 20 to the equation simplifies to 42 equals 50 minus n of cake and ice cream, which means n of cake and ice cream equals 50 minus 42 equals 8. Your turn 132. Ravi and Priya are serving soup and salad along with the main course at their wedding reception. The reception will have a total of 150 guests in attendance. A total of 92 soups and 85 salads were ordered, while 23 guests did not order any soup or salad. 1. How many guests had soup or salad or both? 2. How many guests had both soup and a salad? Who knew? The real inventor of the Venn diagram. John Venn, in his writings, references works by both John Boole and Augustus de Morgan, who referred to the circle diagrams commonly used to present logical relationships as Euler's circles. Leonhard Euler's works were published over 100 years prior to Venn's, and Euler may have been influenced by the works of Gottfried Leibniz. So why does John Venn get all the credit for these graphical depictions? Venn was the first to formalize the use of these diagrams in his book Symbolic Logic, published in 1881. Further, he made significant improvements in their design, including shading to highlight the region of interest. The mathematician C.L. Dodgson, also known as Lewis Carroll, built upon Venn's work by adding an enclosing universal set. Invention is not necessarily coming up with an initial idea. It is about seeing the potential of an idea and applying it to a new situation. Here's some references. Drawing conclusions from a Venn diagram with two sets. All Venn diagrams will display the relationships between the sets, such as subset, intersecting, and or disjoint. In addition to displaying the relationship between the two sets, there are two main additional details that Venn diagrams can include: the individual members of the sets, or the cardinality of each disjoint subset of the universal set. A Venn diagram with two subsets will partition the universal set into 3 or 4 sections, depending on whether they are disjoint or intersecting sets. Recall that the complement of set A, written A complement, is the set of all elements in the universal set that are not in set A. So we have figure 125, side-by-side Venn diagrams with disjoint and intersecting sets, respectively. So we have universal set, white box. So for A union B complement, there is no connection, so they're disjoint. And then that's when that's disjoint, when the circles don't touch. And when the circles do intersect, A union B complement is, A union B complement is the unshaded region, and then the shaded regions will be parts of whatever the sets are. So A and B, you have A intersect B, that's where they combine, and then you have A intersect B complement, is just where A is not B, but it's not part of the intersection, and then B intersect A complement, you also omit the where they intersect. Yeah, that makes sense. Example 133. Using a Venn diagram to draw conclusions about set membership. So we have the universal set equals the set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have figure 126. That's the universal set. A has 1, 3, 5, 7. B has 2, 4, 8, 6. 0 and 9 exist in the rectangular region outside the circles. And both circles are disjoint. 1. Find A union B. 2. Find A intersect B. 3. Find B complement. 4. Find N of B complement. Solution. 1. A union B equals the set 1, 2, 3, 4, 5, 6, 7, 8. Because A union B is the collection of all elements in set A or set B or both. 2. Because A and B are disjoint sets, there are no elements that are in both A and B. Therefore, A intersection B is the empty set. 3. The complement of set B is the set of all elements in the universal set that are not in set B. So B complement equals the set 0, 1, 3, 5, 7, 9. 4. The cardinality or number of elements in set B is N of set B equals 6. Your turn 133. So rectangle U equals same set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. However, now the Venn diagram shows A and B intersecting. A contains 1 and 9. B contains 2. The intersection of A and B is 3, 5, and 7. And the complement of A and B is 0, 4, 6, 8. 1. Find A intersect B. 2. Find A union B. 3. Find A intersect B complement. 4. Find N of A intersect B complement. Example 134. Using a Venn diagram to draw conclusions about set cardinality. So, got blank rectangle, or white rectangle, U. We have intersecting circles A and B. A contains 7, B contains 2, intersection contains 5, and then in no man's land, you got 8. Figure 127, Venn diagram with 2 intersecting sets and number of elements in each set indicated. 1, find N of A or B. 2, find N of A and B. 3, find N of A. Solution. The number of elements in A or B is the number of elements in A union B, so N of A union B equals N of the set 2, 5, 7, which is 14. What? That doesn't make any sense. It should be 3, right? Where's the 14 coming from? Did they just add all the numbers together? Okay. That doesn't seem right. Yeah, because the N is supposed to give you the number of elements, and there's only 3 elements within that set. So I think they just added those numbers together instead of... So I'd say that's a textbook error. Sorry. 2, the number of elements in set A and set B is the number of elements in the set A intersection set B. So N of set A intersect set B equals... should be 1. Because there is only... 1 element in the intersection. Yeah, that's a typo too. And then 3, the number of elements in set A is the sum of all the numbers enclosed in the circle representing set A. They have it as 12, but I'll need to go back through that again because it's saying number of elements and the sum of the numbers. So there's obviously an error there. So whenever I go through this again, because I'll definitely watch this and make comments, and I'll make sure to specify that. Make sure to specify that error. Okay, your turn 134. So we have Venn diagram with 2 disjoint sets and number of elements in each section. Universal set is rectangle, blue circles, A. Yeah. So we have A contains 23, B contains 17, and then rectangle contains 10. 1, find N of A or B. 2, find N of A and B. 3, find N of A complement. Oh, never mind. Okay, I'm sorry. I misread this. Going back to figure 127, number of elements. So the number that's in there is just saying there's 7 elements, 5 elements, 2 elements, 8 elements. So yeah, you would add those numbers together. So when you're looking for the cardinality, you actually add those up because each of these is the number of elements. And I'll make sure to make that more clear in the future. I can still do that. All right, cool. That's it. That's 1.4. Let me just browse